Good day, everyone, and welcome to where we are putting together solutions to those problems in math and science that we are struggling with. In this video, we'll be looking at the topic of vectors in CSEC Mathematics and the past paper questions from the years May 2009 to 2013. Feel free to like the video and add any comments down below so we can make other videos to help you. Let's look at the major topics in CSEC Mathematics, of which there are 10. And we will be looking at number 9, vectors and matrices, which comes in the second section of paper 2. At this point in time, it comes as 4 multiple choice questions, 4 out of 60 in paper 1, and 1 full question worth 12 marks out of 100, and they are compulsory. However, as we're looking at the older past paper questions, the format of the exam was different. In 2009, vectors and matrices did not come in paper 1, and when it came in paper 2, they came as 2 separate questions. Vectors worth 15 marks and matrices worth 15 marks by themselves. And students were able to choose both, one or none of them if they wanted to. In 2010 to 13, the format had changed. There were still no questions in paper 1 multiple choice, but in paper 2, the question of vectors and matrices was put together and it was worth 1 full question or 15 marks. So from 2010 to 13, the vectors questions were worth half of that 15. So approximately 7 or 8 marks for each year compared to 2009. May 2009, number 13, part A. The points A and B have position vectors OA equals to minus 2, 5 and OB equals to 4, 2, where O is the origin, 0, 0, the points of intersection between the x and y axis. The point G lies on the line AB such that AG is equal to 1/3 AB. Express the following in the form xy as a column vector. Now, I found that the easiest thing for my students would be to make a little sketch. So let's sketch the x and y axes, and the point of intersection is O. And let's see, OA is minus 2, 5. The top value gives us the direction we have to move in the x-axis. So from O, we have to move minus 2. So we're moving 2 to the left, and then we're moving 5 units in the y direction, plus 5, which means 2 to the left, 5 up. So OA, we draw as a blue arrow starting from O, going to the top left to A. And it's a sketch. Let's continue. OB is 4, 2. So we're moving plus 4 in the x direction, which means we're moving 4 to the right, and 2 in the y direction, meaning we're going up 2. So OB would be a blue line that we have drawn moving to the top right. And if we have OA and OB, we can now connect A and B by drawing a purple line from A to B. And it's telling us that AG is equal to 1/3 AB. And G lies on that line. So 1/3 of the distance between A and B will be G. So we average about a point where G lies. Let's go solve. For part 1, they would like us to write as a column vector AB. And let's see if we could write a formula. AB, to go from there, would mean we're going from A, we're starting from A, and we're going to O. So that's AO. And we're at O, and we're heading to B, OB. Now, if this formula is correct, let's look at the inside letters. Both letters on the inside are the same. So we're starting from A, heading to O, taking a rest, then starting back at O and heading to B. So it's like moving from A to B. So if we have our formula, now let's see if we could substitute. We don't actually have values for AO, we have for the opposite, OA. And what's the difference between one and the other? The direction. So we can rewrite that line we have in red as AB is equal to minus OA plus OB, because minus OA is the same as writing AO. And as we substitute the values, AB is equal to minus the column vector minus 2, 5 plus 4, 2. And we can solve by working out the top value for x. Minus 2 plus 4. That's 2 plus 4 is equal to 6. And minus 5 plus 3 is equal to minus 3. So we have AB. And for the next part, they're asking us to find the column vector for AG. And we have a formula. They gave us AG is equal to 1/3 AB. So let's substitute after our formula. So AG is equal to 1/3, 6 minus 3, which we just worked out from above. And 1/3 of 6 is equal to 2, and 1/3 of minus 3 is minus 1. So AG is 2 minus 1. Now if we look at both of these, we can see from our sketch, from A, if we are heading towards B, we're going to the right, which is positive, and then we're going downwards. So the Y value will be negative. And if you look at AB, we got 6 minus 3, positive to the right and negative in the Y direction or downwards. And AG would be similar, which is 2 to the right and 1 downwards. Now let's work out part 2 for 2 marks. The position vector OG. So if we're moving from O to G, we can write a formula. Let's start at O, but let's pass in a different direction. So from O, we can walk to A. So that gives us OA. Take a rest. And then we start back at A and head to G. So the formula we've just gotten was OG is equal to OA plus AG. Vectors are quite common sense. So let's think about walking from one direction to the other. So let's substitute now that we have our formula. OG is equal to minus 2, 3 plus 2 minus 1. Values that we have given above or calculated before. So OG is equal to, let's see the x values. Minus 2 plus 2 is equal to 0. And OG, the y value is 3 plus minus 1, which is 2. So OG is 0, 2. What does that mean? It means that if we are starting from O and we're heading to G, we do not have to move to the right or left. That means we're staying on the y-axis and we're going up 2 units. So our sketch is a little off, but our sketch is just to give us a guide of generally where the things are placed. If we drew them exactly using graph pages, you would find that OG would be, G would fall exactly on the y-axis if it's 1/3 the distance from A to B. May 2009, number 13, part B. In the diagram below, not drawn to scale, so they're giving us a diagram in this situation. B is the midpoint of OX. C is the midpoint of AB. And D is such that OD is equal to 2DA. So OD is twice as long as DA. The vectors A and B are such that OA is equal to 3A. So let's put that in. And OB is equal to B. So if OA is equal to 3A and OD is twice as long as DA, then we can say OD is 2A and DA is A. Now, write in terms of A and B, the vector AB. So if we're going from A to B, how can we pass? We can start from A and head to O. So that's AO, and then take a rest. And when we get back up, we start back at O and we continue to B. So we wrote a formula, AB is equal to AO plus OB. And we don't have AO, but we have OA. So how do we switch it? By changing the sign. So AB is equal to minus OA plus OB. Remember, if we're going from O to A, that is 3A. That's heading to the top right. We're actually going in the opposite direction, so it'll be minus 3A. So from A to O, it's minus 3A plus B. And that gives us AB. Now AC is equal to half of AB. And how do we know that? Because they told us that C is the midpoint of AB, it's halfway. So AC would be equal to, let's substitute half, and in brackets minus 3A plus B, which we got in part A. Let's look at DC now. How do we go from D to C? We can go from D to A plus A to C. So if we walk from D to A, then we took a rest at A, then we got up and we walked from A to C, that would give us the same thing as if we walked in a straight line from D to C. So what do we know? DA is equal to A plus AC, we worked out in part B, is a half minus 3A plus B. Now it becomes a simple algebraic expression. So we can expand. So we have A plus a half times 3A. A half times 3A is minus 3 on 2A. So 1A plus minus 3 on 2A is minus a half A. You can use a calculator and work this out because this is in the paper too. So let me show you how to, let's repeat that. We have 1A plus a half times 3. And that will give us minus a half A plus a half B. And if we want, we can extract the minus a half from it. And we'll get minus a half and in brackets A minus B. Now let's look at part D, dx. So how do we go from D to x? We can go from D to O and then from O straight to x. Now D to O is equal to minus OD because OD would be going upwards to the right and we're actually heading in the opposite direction. So we have to go to the negative of that plus 2OB. Remember, B is the midpoint of OX. It's given above. So if we substitute, dx is equal to minus 2a plus 2b. OB is equal to small b, so OX would be 2b. And if you want, we can factorize minus 2 out of it again, and we get minus 2 brackets a minus b. So either of them we could have left the answer as, and it would be correct. So those 4 parts was worth 6 marks. Now let's look at part 2. State 2 geometrical relationships between dx and dc. Well, if we look at dx, we got minus a half a minus b and minus 2 times a minus b. So it means that both of them are parallel and they are scalar multiples of each other, meaning they're heading in the same direction except one is a multiple of the other or an enlargement of the other. And in part 3, state one geometrical relationship between the points D, C, and X. Since they are all parallel and scalar multiples of each other, plus they share the point C and D, then they are collinear. May 2010, number 11b. The diagram below, not drawn to scale, shows triangle JKL. So we have a triangle with its vertices labeled as such. M and N are points on JK and JL respectively, such as JM is equal to 1/3 JK. So that means M lies on that JK, that top line, but it's closer to J than to K. And JN is equal to 1/3 JL. So N lies on JL, but it's closer to J than to L. Part 1. Copy the diagram and show the points M and N. And we've just done that. Given in part 2 that JM is equal to U, well, let's put that in. And that means we're moving from J to M. We're going to the right, and that will be U. So if we are going to the left, it will be minus U. And Jn is equal to V, so let's put that in as well. Write in terms of U and V an expression for JK. So let's take a look at that. And let's think about it a little bit. They gave us that Jm is equal to 1/3 JK. So if I want to find JK, I can carry the 1/3 across. The 3 is dividing. When I carry it across, it will multiply. So that will mean it will give us JK is equal to 3 times Jm. And we know Jm is equal to U. So JK is equal to 3U by simple substitution. In part B, find Mn. So if we want to go from M to N, we can move from M to J and then from J to N. And let's see, M to J means we're going minus U because we're going to the left, and Jn is equal to V. So Mn is equal to minus U plus V. Part C now, KL. To go from K to L, we can go from K to J and then from J to L. K to J is actually the negative of part A of JK. So jk, we got 3u. So kj will be minus 3u plus, what is gl? 3 times v. So we have minus 3u plus 3v. And we can factorize and pull out the 3. We'll end up with 3 brackets minus u plus v. In part 3, using your findings in B part 2, deduce two geometrical relationships between KL and MN. So let's look at both of them. Both of them have minus u plus v. So if we actually write KL is equal to 3 minus u plus v, we can substitute for minus u plus v as Mn. So what does that mean? It means that they are scalar multiples of each other. So KL and Mn are parallel, that's 1, and KL is 3 times longer than Mn. 2011, number 11C, WXYZ is a parallelogram in which VY, that's the line on the base, is equal to A, and VW, the line on the left, is equal to B. And the directions are little arrows. They're showing us which way they're going, to the right and up. S is a point on WY such that WS to SY, that ratio is 1 to 2. So they've given us this diagram and we can put in that information that WS, we can put in 1 there and SY is equal to 2. And that will be useful later on. So let's look at part 1. Write in terms of A and B an expression for WY. So WY, how do we go from W to Y? We can write in formula. We can start from W and head to V, and then from V to Y. Now WV, the magnitude is small b, but it's heading in the opposite direction. So it's minus b plus e. Now for part B, what is WS? Now we know WS is in a ratio 1 to 2. So that means it's 1 out of the entire length of 3. So WS is 1/3 of WY. So if we look at that and we use in part A to substitute, we'll get 1/3 by minus b plus e. And we can leave it like that, or we can expand it either. Part C now, find SX. We're drawing a line from S to X as a red arrow. So how do we pass here? We can go from S to W and W to X. Now SW is minus of what we've just found in part B. It's the same magnitude, 1/3 minus b plus a, but it's in the opposite direction. So we have to put a negative sign in front of it. So it's minus WS. And what is WX? It's the same as the base line, VY, because it's a parallelogram. So we can now substitute for them. So SX is equal to minus 1/3 by minus b plus a plus e. And we can expand and simplify. So minus 1/3 by minus b is equal to 1/3 b. And minus 1/3 by a is equal to minus 1/3 a plus e. So that, if we simplify, we're going to get 2/3 a plus 1/3 b. And if we can leave it as is, or we can multiply throughout by 3 every single term on the left and right, and we'll get nice whole numbers. So we'll get 3sx is equal to 2a plus b. Now let's look at part 2, the last part of the question for 3 marks. R is the midpoint of VW. So they're telling us that, so let's put it in as a blue arrow. Prove that R, S, and X are collinear. So let's see, RS, how do we get that? We can go from R to W and from W to S. What is RW? Half of VW. It's heading in the same direction, so we don't need to put a negative sign, but it's half the magnitude, half the length. And we have WS from before in part B. So we can just substitute. We get a half B plus 1/3 brackets minus B plus A. And we can expand the bracket, so we get a half B minus 1/3 B plus 1/3 A. And we can rearrange and simplify, and we'll get 1/3 A plus 1/6b. Remember, we have our calculators, so we can use the fractions mode and simplify easily. And just like before, instead of looking at fractions, we can multiply throughout by a number. So let's multiply by 6 on the left and right. So it will give us 6rs is equal to 2a plus b. Looks similar to the one before. So part 2, we had to prove that they're collinear. Let's take a look how. 2a plus b is equal to 3sx and it's equal to 6rs. As such, rs and x are collinear because they're parallel to each other and they share a point. So now that we've proven it, we can put the small rectangle or write QED, quod erat demonstrum. May 2012, number 11a. The points A, B, and C have position vectors OA equal to 6, 2, OB equal to 3, 4, and OC equal to 12, 2, respectively. So let's make a little sketch because no diagram was given. So it gives us an idea how these points are situated. So let's draw the x and y values, and we put the center as O, being the origin. And OA is equal to 6, 2, means we're moving to the right 6 and up 2. So we can put in A there. And OB is equal to 3, 4. So we're moving to the right 3 and up 4. So we're just averaging to give us an idea of the sketch. We don't need to do anything accurately. And OC is equal to 12 minus 2, meaning we're moving 12 to the right and 2 down. So we're all moving to the right. A and B went upwards and C went downwards. Expressed in the form xy, the vector BA. So if we draw that with a purple arrow, as we connect the points B to C, then we can see BA. How do we go from there? Well, BA, we can go from B and walk to O, and then from O, we can go to A. Now, we don't have BO, but we have OB, the exact magnitude, but in the opposite direction. So how do we deal with that? Well, we say BA is equal to minus OB, as the direction is the opposite, plus OA. And we can substitute. So BA is equal to minus 3, 4, plus 6, 2. And we can solve, let's work out the top. Minus 3 plus 6 is equal to 3. And the y values, minus 4 plus 2 is equal to minus 2. So BA is equal to 3 minus 2. That means that if we're moving from B to A, we move 3 units to the right and 2 units down. And our sketch shows that general area. Now part B, expressed in the form BC. So how do we go from B to C? Well, from B to C, we can go from B to O, and then from O to C. And we do similar substitutions. BC is equal to minus OB plus OC. BC is equal to minus 3, 4 plus 12 minus 2, which we were given above in the question. And we can work it out. Minus 3 plus 12 is equal to 9. And minus 4 plus minus 2 will be minus 6. So BC is equal to 9 minus 6. And if we look at our sketch, we're moving 9 units to the right and 6 units down. So we're kind of going downwards to the right. Good. Part 2, state one geometrical relationship between BA and BC. Well, if we look at BC and we factorize 3 outwards, then we get BC is equal to 3 brackets 3 minus 2. And what is 3 minus 2? BA. So BC is equal to 3 BA. So one geometrical relationship we can say is that they are parallel to each other. And we can, if they needed a second one, we can say they're a scalar multiple of each other as well. Part 3, draw a sketch to show the relative positions of A, B, and C, and we've been doing that all along. Whether or not they asked us that, the best advice for doing vectors questions, if no diagram is given, is to make a sketch. May 2013, number 11a. In the diagram below, not drawn to scale, P and Q are the midpoints of OA and OAB respectively. OA is equal to 2A, so let's put that in the diagram. And OB is equal to 2B, so let's put that in as well. One of the habits to help ourselves is as we make a sketch, whatever values we've worked out, we can put it on the sketch. It may help us with other parts in the question. So part 1, express in terms of a and b the vectors ab worth 2 marks. So how do we go from a to b? We can go from a to o and then o to b. And AO is minus OA because it's the same length of magnitude but the opposite direction, and OB. So we can substitute AB is equal to minus 2A plus 2B. And we could leave it as this, and that's fine. Or if you want, we can factorize out the 2 and we're left with 2 brackets minus A plus B. Now part B. Do the same for PQ. So how do we go from P to Q? We can go from P to A and then from A to Q. Now remember, P is the midpoint of OA. So if the whole length was 2A, that means from P to A, it would just be A. And AQ is such that it is half of the AB because Q is the midpoint of AB as given above. So we can substitute PQ is equal to PA plus AQ, PA is equal to A, and AQ is equal to half to B minus A. Now, let's expand and solve. So that will give us A plus a half times 2. They'll cancel each other. So we're left with B minus A. So A, and let's simplify. A minus A cancels. So we're left with B. PQ is equal to B. And part 2 of the question. State 2 geometrical relationships that exist between OB and PQ, giving reasons for your answer. Well, since OB is equal to 2B, that means that OB is equal to 2 times PQ. So that tells us that they are parallel. These two lines, OB and PQ, are parallel to each other. And they are also scalar multiples, as one is twice as long as the other. This brings us to the end of the CSEC past paper questions on the topic of vectors from May 2009 to 2013. Our next video, we will be doing the years 2014 to 2018.